Hello friends, in this video I'm going to solve the numerical problems which were asked in AHSEC final examination under Assam Higher Secondary Education Council from this chapter Electromagnetic Induction. Okay, so before we start, please do subscribe the channel, hit the thumbs up button, also share with friends, inspire me to create new contents for you and help me to grow my channel. And if you get the hype option, please do hype the video. Okay, and if you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT123. that's my Insta ID. You can follow me on Insta. So now let's start. So this question was asked in AHSEC final examination 2023 under Assam Higher Secondary Education Council. Okay, so now let me show this question. So here a current of 4.0 ampere is flowing in a coil. If the current suddenly falls to 0.0 ampere, okay, in 0.1 second, an average EMF of 200 volt is induced. Okay, calculate the coefficient of self inductance of the coil. Okay, so here it is given that here you see the current in a coil, the current I that drops from 4 ampere to 0 ampere, right? 4 ampere to 0 ampere in 0.1 second. So that means we can say that rate of change of current di by dt, its magnitude is 0 ampere minus 4 ampere divided by time 1 second, sorry 0.1 second, right? That is the time given. Okay, so hope you have understood this. So it's gonna be equal to minus 4 by 0.1 mod means here we're gonna ignore the minus sign. Okay, and 4 divided by 0.1, that means 40, right? That's going to be 40 ampere per second, right? That's what we have got. So average EMF is given. Average EMF is 200 volt. Okay, average EMF is 200 volt. We need to find the self inductance, that is L, right? So now you see, let me clean this. So how to solve this? We know that EMF, its magnitude is given by d phi by dt, rate of change of flux, right? Rate of change of flux. And we know that phi, this flux, is directly proportional to current, and here we need a constant, that is self inductance L. So we know phi is equal to Li. We know this relation. So we can write that EMF is equal to, here we can write mod of di dt, right? And that's gonna be okay. So here it implies that we know that average EMF is 200. So let me put 200 volt here, and we need to find L, and di by dt we have got 40 ampere per second. So here 40 ampere per second, that's what we have got. So therefore L will be equal to 200 divided by 40. Sorry, it's supposed to be 40. So this is 40 ampere per second. So this L is equal to, which is self inductance, that's going to be equal to 200 divided by 40, okay, Henry. Its unit is Henry. So that's going to be equal to 5 Henry. So cancel 200 by 40, then it's going to give you 5 Henry, right? So now let's move on to next question. Okay, this question was asked in 2023 AHSEC final examination 2023 under Assam Higher Secondary Education Council. So a long solenoid having 15 turns, number of turns 15 per centimeter. Okay, that means turns per unit length is 15 per centimeter, has a small loop of area is given 2 centimeter square, placed inside the solenoid normal to its axis. If the change of current in the solenoid is 2 ampere, change of current is given in 0.1 second. Find the induced EMF in the loop. So here you see, so first let me write the given information. What are the given information? 15 turns per centimeter, right? 15 turns per centimeter, that means small n is equal to capital N by L. So 15 turns per centimeter, so it can be written in turns per meter. So that's gonna be, centimeter will be equal to 1 by 100. So that's why in meter that's gonna be 1500 turns in 1 meter. So 15 turns per meter, right? So, and the area of the cross section is given. So area of the loop area is given, that is 2 centimeter square. 2 centimeter square. So let me convert this one into meter square. That's going to be 10 to the power minus 4 meter square, right? Because centimeter to meter, if you want to convert, then you need to multiply 10 to the power minus 2. Now we are converting centimeter square, so you need to square it. So that's going to be 10 to the power minus 4, right? Hope you have understood this. And rate of change of current is given. So di by dt, change in current is 2 ampere in 0.1 second. So that's gonna be equal to 20 ampere per second. That's gonna be equal to 20 ampere per second, right? So what we need to find that here. So now you see, inside the solenoid there is a loop, and this loop is perpendicular to the axis of this solenoid. Okay, now you see, we need to find the induced EMF in this loop. Okay, so we know that flux through this loop inside the solenoid will be phi is equal to B into magnetic field into area of this loop. Okay, area of this loop is given. This is the area of this loop. And magnetic field inside a solenoid, we know that is equal to B is equal to mu naught N I. We know that. So that's why we can write this way. We can write that flux is equal to phi is equal to magnetic field, that is mu naught N I into area of cross section A. And actually phi is equal to B dot A, right? So here this loop inside the solenoid is perpendicular to this axis of the solenoid. That's why the area vector of this loop will be also in the same direction, as this axis. You can say that the area vector of this loop and the axis will be parallel, so that's why theta will be 0. So we can simply write B dot A cos theta, that means cos 0, that is B dot B into A. So here magnetic field is this and area is this. So hope you have understood this. So now, so what do we need to find? Induced EMF. So induced EMF is, we know that induced EMF is d phi by dt, right? So d phi by dt. So if we use that here, instead of phi, what we're going to use? We're going to use mu n into a I, right? Mu n I a. So here only the thing, only the quantity which is changing here is current I, and remaining quantities are constant. So mu naught n a, these three are constant, so we can write out of the differential coefficient here. That's why we're gonna have only di by dt, and we know this di by dt, rate of change of current, is 20 ampere per second. So let me put here 20 ampere per second instead of di by dt, right? Let me write it properly. Okay, so induced EMF is now mu naught n into a di by dt. So here mu naught is 4 pi into 10 to the power minus 7 into small n, that is number of turns per unit per meter is 1500 into area of cross section. We have got 2 into 10 to the power minus 4, and di by dt we have got 20. Okay, if we multiply all this, what we're gonna have? We're gonna have 7.5 into 10 to the power minus 6 volt, right? Hope you can do the calculation by yourself. I don't think I need to show you how to multiply. Okay, so this is the induced EMF. So now let me take the next question. Here is the next question. This was asked in AHSEC final examination 2022. Okay, so rainy season, in a rainy season you are running with your umbrella opened in a place where the horizontal component of earth magnetic field is this 0.26 gauge. Okay, if the length of your umbrella is 80 centimeter and your speed is 20 km per hour, calculate the motional EMF developed across itself. Okay, so now here the magnetic field is given 0.26 gauge. Okay, so now let me convert this one into Tesla, that is 0.26 into 10 to the power minus 4 Tesla. Okay, and length of the umbrella is 80 centimeter. Sorry, it is 80 centimeter. So let me convert this into meter, 0.8 meter, right? And velocity, with who is the person who is holding the umbrella, if it is you, then that means you are running with 20 meter per second. Sorry, 20 kilometer per hour, not meter per second, 20 kilometer per hour. So let me convert this one into meter per second. So 20 kilometer in meter, that is 1000, and 1 hour in seconds, 60 into 60, right? And this is meter per second, and if we cancel and simplify this, 50 by 9 meter per second, that's what we're gonna have, right? So now motional EMF, we know that motional EMF is given by E is equal to BLV. Okay, BLV, hope you know this. Okay, motional EMF. First do watch all the previous videos on this chapter, that I have already solved many questions which were asked in AHSEC final examination. Okay, so here I am solving only numerical parts, so links are in the description box. Okay, motional EMF is BLV. We have already proved in previous video, which was also asked in previous year examination, AHSEC final examination. So here magnetic field is 0.26 into 10 to the power minus 4, and length is 0.8, and V is 50 by 9. And if we calculate all those, then if we multiply all those, then motional EMF will be approximately 1.155 into 10 to the power minus 4 volt, right? So hope you have understood this. Now let me solve the next question. Okay, so this question was asked in AHSEC final examination 2020, okay, under Assam Higher Secondary Education Council. So in this question, we have, in a circuit, current decreases from 5 ampere to 0 ampere. So rate of change of current is given here, 5 ampere to 0 ampere in 0.1 second. So we can say that rate of change of current di by dt, we're gonna take its magnitude, so mod of di by dt, so that's gonna be 0 ampere minus 5 ampere, because it is decreased from 5 to 0, right? So final result minus initial, final current minus initial current, divided by the time taken, that is 0.1 second. Okay, 0.1 second. So we can say that it's gonna be 5 by 0.1, that means 50 ampere per second, right? So this one gonna be equal to minus 5 by 0.1. That means minus 50 by 1, right? So here we are taking mod, that's why I am writing here positive, right? Hope you have understood this. So now you see, okay, so magnitude of induced EMF is 200 volt. Here induced EMF is 200 volt. We need to calculate the self inductance, that is L, right? So we know that E is equal to this induced EMF we have already discussed earlier, right? Di by dt, L into di by dt, 200. So di by dt we have got, this is equal to 50, 200. So 50 cancels 200, right, to give 4. So that's why L is equal to 400. So this is the answer, right? So this is the self inductance. Okay, so here it is given, right? It's SI unit. SI unit is Henry. Okay, so now let me take one more question, the last question, which was asked in 2020. So this was also asked in 2020. Okay, AHS final examination. So when a coil of area is given, so let me write the area here, 5 meter square. Okay, 5 meter square. Number of turns is 100. Number of turns is given is 100. Is placed perpendicular to a magnetic field. Okay, this is the suppose magnetic field, and the coil is placed perpendicular to this magnetic field. Okay, the coil is perpendicular to the magnetic field. That means area vector of this coil is parallel to this magnetic field. Area vector of this coil will be parallel to this magnetic field. Hope you have understood this, right? So when you say area vector, if this is the coil, then area vector is its area vector is always perpendicular to this coil actually. So if you see, this is the coil, and if this is the area of the coil, then area vector is perpendicular to this coil. Okay, area vector is perpendicular to this coil. And magnetic field, if the magnetic field is perpendicular to this coil, then this must be parallel to the area vector, right? Hope you have understood this. Now you see flux passing through it, and one more thing, magnetic field is given here 10 Tesla. Magnetic field is given here 10 Tesla. So this coil is placed in a magnetic field of 10 Tesla, and flux passing through it is given flux, that means phi, that is 5 into 10 to the power 3 Weber, right? And if the coil is removed from the field in 0.1 second, it is removed in 0.1 second, we need to calculate the induced EMF. So that's very simple. And induced EMF, that's going to be equal to number of turns, capital N, and we know that rate of change of flux. Okay, so when the coil is removed in 0.1 second, okay, that means this flux will be changed to 0 in 0.1 second. So rate of change of flux d phi by dt, that's going to be equal to 0 minus 5 into 10 to the power 3, that's going to be minus 5 into 10 to the power 3 divided by 0.1. As we have modulus here, we are taking modulus here, so we're going to consider the numerical value, not the negative sign here. So that's what we're going to have. And as we have decimal here, 0.1 divided by 0.1, so we can make it like this. And so what we will get, 1000 on removing this decimal into 5 into 10 to the power 3, and if we multiply this, then we're gonna have 5 into 10 to the power 6 volt. So this is the induced EMF. So hope you understood this.